I'm Associate Professor Simon Chu from the Hudson Institute, and I've been working in medical research for over 25 years with a particular focus on ovarian cancer. I started my career studying hormone receptors and how they influence reproductive health. Early on, I became fascinated by granulosa cell tumours, or GCTs, a rare subtype of ovarian cancer that behaves differently from other ovarian cancers but is just as devastating. One of the most challenging things about this cancer is that it can come back decades after initial diagnosis. And when it does, it is almost incurable. So even if a patient is told there's no evidence of disease, there's always risk of recurrence. That's why my team is focused on finding a way to stop it from coming back. Nearly all women with this cancer carry a mutation in the FOXL2 gene, which interacts with a key family of proteins, which we believe play a key role in driving tumour growth. So with support from the OCRF, we're investigating how to block that interaction using cutting-edge techniques such as cryo-electron microscopy to map out the molecular structure of that faulty interaction. Once we understand that, we'll screen a large drug compound library to find ones that might stop that interaction and thus stop tumour progression, and potentially lead to targeted treatment for all patients with this mutation. So right now, there are no long-term effective treatments for granulosa cell tumours, and recurrence can happen 10, 20, even 30 years after its initial diagnosis. Because it's a rare ovarian cancer, it has been historically underfunded, leaving patients with limited options beyond surgery. In this research, if we can successfully block the interaction of FOXL2 with a family of proteins called the SMADs, we may be on the path to a potential cure for the vast majority of adult GCT patients who carry that mutation. That's why this research is so important. This project brings together an incredible team at Hudson Institute made up of scientists, clinicians and research specialists, all working together to find better treatments for GCT. In the lab, I have a dedicated team of 3 research assistants and 3 PhD students, each bringing unique expertise to the project, whether it's cell biology, drug screening or genomics. Their hard work is what keeps our research moving forward every day. On the clinical side, I'm fortunate to be mentored by Professor Peter Fuller and Professor Tom Jobling, 2 highly respected leaders in endocrinology and ovarian cancer research. Their clinical insights help bridge the gap between our discoveries in the lab and how they might be applied to the real-world patient treatments. Our lab is working to better understand how granulosa cell tumours grow and how we can target them with new treatments. We're also analysing data, looking at patterns that could reveal key insights into tumour biology and thus potential drug targets. But science isn't just about discovery, it's also about communication. So as we generate results, we're writing up our findings for publication, sharing them with the broader scientific and medical community so that our research can contribute to the global effort to improve treatments for ovarian cancer. It's a dynamic and challenging process, and every step brings us closer to better outcomes for patients with this rare ovarian cancer type. I want to give a special thank you to all the members of the lab, OCRF's amazing community of monthly givers. Your ongoing support provides secure and sustainable funding for researchers like us, funding we may not be able to get elsewhere. Thanks to you, we come to work every day knowing there's an entire community backing us, helping to drive new discoveries in ovarian cancer research. Breakthroughs take a team, and we are incredibly grateful to have you on ours. So thank you.